We're now going to continue to look at the polynomial f of x equals 3x cubed minus 14x squared minus 7x plus 10. And we're going to find all those zeros. Now, in the previous video, we determined that the possible rational zeros are, and we got this long list, right? I won't read off all those numbers. And it seems like a lot of possibilities, but try to realize it eliminates a lot of, it tells us that a lot of numbers are not zeros. For instance, 3 or negative 3 cannot be zeros of this polynomial. So now we want to find the actual zeros. We think there will be some numbers in this list that turn out to be zeros. Most of them will not. And so what we have to do is start checking or start looking for actual zeros. And so I have to start working my way down this list. So first, let's try 1. So basically I would try 1, then negative 1, 2, then negative 2, 5, then negative 5, until I found one, right? We're going to go down the list. And the way we're going to do that is we're going to use synthetic division. So I'm going to write down the coefficients of my polynomial f, 3, negative 14, negative 7, 10. And in front, I'm going to write just a 1. It's like we're dividing by x minus 1. But we're dividing by x minus 1 because the remainder will be f of 1. The remainder will be f of 1. And we're trying to find out, is f of 1 0 or not? If it is, 1 is a 0. If it's not, we didn't find it. So here we go. Bring down the 3. 3 times 1 is 3. Negative 14 plus 3 is negative 11. Negative 11 times 1 is negative 11. Add these two together, I get negative 18. Negative 18 times 1 is negative 18. 10 plus negative 18 is negative 8. So this last number that we got is the remainder. It's also equal to f of 1. And so what we can see is, 1 is not a 0 because we didn't get 0. Okay, well, I feel a little bit bad, but I don't feel too bad because I'm going to keep looking. Try, so I would say next, we're going to try another possible rational 0. And now, you can go through those possible rational zeros in any order, but I try to work with the easiest numbers first. So we're going to try negative 1. So I got to just do the synthetic division again with 3, negative 14, negative 7, 10. And I'm going to write a negative 1 there. So the remainder will be f of negative 1. And we just go through this process. So synthetic division makes it really easy for us to check these values, right? To come up with these function values and see where we get 0 function value. So I brought down the 3, multiplied, added. I got to multiply. I get 17. I get 10. Multiply. I get negative 10. Add. I get 0. There we go. F of negative 1 is 0, so negative 1 is a 0 of the polynomial, also we know that x minus a negative 1 or x plus 1 is a factor. And we can use the fact that we have the coefficients of the quotient here to write our original polynomial in factored form. Now, 10 is the constant term, x squared term. So this stands for 3x squared minus 17x plus 10 is our quotient. And so what we have is as follows. I'm going to recopy the original polynomial. 3x cubed minus 14x squared minus 7x plus 10. And we know this factors now into x plus 1 times the quotient 3x squared minus 17x plus 10. So we found 1 0. We're still looking for more. Now, whenever we get a quadratic, so we got a quadratic factor at this point, we can always try to factor by hand a quadratic factor. So I don't have to go through the whole synthetic division process to break down this 3x squared minus 17x plus 10. I mean, I might not have to. Let's see if just using good old-fashioned factoring techniques we can break this down further. Because if we can, then we'll be able to see what the remaining zeros are without having to go back to our long list. So if this is going to factor, it would have to be 3x and x. Minus in the middle, plus on the end, tells me that both signs would have to be minus if it's going to factor, because that's the only way to get a positive third term and also have a negative middle term. So I have either 10 and 1 or 5 and 2. You're going to have to play around with this a little bit. I think 2 and 5 is actually going to work because I get negative 15x plus a negative 2x is negative 17x. That works. We got it. Got it. And so now I can see what the other zeros are, right? So the zeros of f of x are, the actual zeros are, now we already had negative 1, I'll leave that in my list. If I set this factor equal to 0, 3x minus 2, I think you can see we're going to get 2/3. Now that was on our list somewhere of possible zeros. We wouldn't have found it for a while if we went through systematically, so we're lucky we were able to factor here. And my other one is 5. And that was also on our list. But again, because we got down to a quadratic factor, then we can use old-fashioned factoring techniques to factor, hopefully. And once we have the factors, we can just read off what those other zeros are. So we found the zeros for, I'm just going to circle this because this was the original polynomial. So we've worked on this same polynomial for 2 problems, and we got it factored, and we found its zeros. And that's it for this video.